Hi, welcome back. This is Lokesh, and we just completed one activity in which we saw how to query for ancestors. That is, query based on ancestors. That is between two kinds of tables or two tables. So this querying over here is slightly different than querying and filtering and sorting. It's different than your normal SQL. Now what we'll do is we'll see what are the limitations which are there on queries. So when we are looking at queries for data stores, inequality filters are restricted to at most one property. Properties used in inequality filters need to be sorted first. Sort orders are ignored on properties with equality filters. Query result order is undefined if sort order is not specified. So you don't know whether it will be ascending or descending or in which order the records will come. Filtering unindexed properties returns no result. So if some property is unindexed, you will not get any result. Entities lacking a property name in query are ignored. Queries inside transactions must include ancestor filters. So the key things which we should remember in this is that there is persistent capable annotation used to create a model in Java data object. The persistent annotation is used to declare a variable of a model class in Java data objects. Make persistent method is used to store data in Java data objects. This was in the previous one which we were doing for the JDO insertion through JDO. The Google Data Store is used to store and automatically scale large volumes of non-relational data. In big table, query is executed as index scan. That means it scans the table, index table, to do a query. The data store query retrieves entities from data store if the specified conditions are met. So if it finds the data in index, it will fetch the records. Data store query operates on entities of a given kind. Data store query can return 0 or more entities as a result. The data store API provides the query class to construct queries and prepare query interface to retrieve entities from the data store. The query class encapsulates a request for 0 or more entities objects out of the data store. The prepared query interface contains methods to fetch and return entities from a query. The offie.load method of the Objectify instance is used to load entities from the data store. Filters are used to set the constraints on the properties, keys, and ancestors of the entities to retrieve. Data store queries can specify filters on the entities, properties, values, keys, and ancestors. Okay, so sorting data helps you to quickly visualize and understand data. Kindless queries does not contain any kind of ancestor filter in it, and query can contain ancestor filter, and it is also known as ancestor query. Kindless ancestor query includes ancestor filter but does not contain any kind. So there are different types of queries. which are there. We just saw one kind of query. Key-only query returns just key of the result entities. So you can study this more online to understand how they work and try it out later on. Now we need to move on to the indexes section. Indexes. Data store indexes. One example I already showed you, automatic indexes which are getting created at the time when we were doing the filtering and sorting. So let's look at the indexes again, and this time we will define the indexes. So what is the difference between the indexes over here and the RDBMS indexes? So index is defined on a list of properties of a given entity kind. That means a particular column, there is an index which is defined. Index can also optionally include entities ancestors. Index table contains a column for every property named in the index definition. Each row of the table represents an entity in the data store. The entity is added in the index only if it has an index value set for every property used in the index. That means when you are going to insert something, its index has to also be updated. The row of the index tables are sorted by ancestor and then by property values in the order specified in the index definition. So I have different values over here. Profile, which is the kind. Profession is the property, and there are different professions like teacher, singer, doctor, etc. So there is index which has been created on the profession, and based on it, it is doing an index scan over here based on which profession people you want to fetch. So if you are checking for teachers, so the key which is here is the teachers key. So it is going to fetch the records related to the teachers. So how do we configure the indexes? We create data store automatically creates an index for each property. So there are these every property has its own index. Using predefined index, users can perform simple queries. For complex queries, users need to manually define index in the data store index file. Data store index.xml file is the one where indexes are defined. We will define it today. App Engine SDK automatically suggests appropriate index to the application. The local development web server automatically generates an index configuration that allows the users to execute the query successfully. Queries with ancestor and inequality filters need to be manually specified in the data store indexes XML file. Queries with multiple sort order or queries with a sort order of keys is in descending order needs to be manually specified in data store indexes.xml file. So if you want to sort on descending order, you need to manually specify the index. There can be two types of there can be properties with mixed value types or unindexed properties. Okay. So if two entities contain properties with the same name but different value types, at first the index of the property sorts the entities by the value type and then set the order that is suitable to each type. So properties, if you want some property to be unindexed, so there is a key tag @unindexed. So property is defined as unindexed ensure that sorting and filtering operation cannot be performed using that property. So you can specify that this field cannot be indexed by applying the @annotation unindexed. So now let's look at how these are implemented. So there can be two types of indexes, single property index or composite indexes. So let's look at single property index. Single property index means on a single column the index is maintained. So if the name is Peter, so it's indexed on the names, and it does a normal range scan if you want to fetch a particular value. So where name equal to Peter, scan with prefix profile name Peter. So it will check and will get it over here right away. Inequality filter or sorting and sorting on single property. Where name is greater than equal to J and name is less than K or K ordered by K. So this is what we want to do. Where name is greater than J and name is less than K, order by name. So how it will work in data store is, it'll do a range scan where parent name is J and parent name is K. So it will scan for the parent name J and parent name K. So these are the different values. So it will find this J, J, K, where name is greater or equal to J and less than K. Sorry, the K will not come. So Jack and John will come. And ordered by name. So Jack has to come before and John will come after that. So two single property indexes are created, one for ascending order and the other for descending order. Because order by is being used, or if you want to use order by, you will need to create two indexes, one is ascending and one is descending. So now let's look at how this can be done. How the single property filtration of data is being done. This is a repetition. Okay, what we'll do is, in this example, there is an employee table which has got employee ID 102, HR manager, employee ID 99, area manager and 8000, employee ID 105, and there is 100 and 110. So in the problem statement, what we are doing is, you need to create an entity of the employee kind which is given in the following table. So we create all these entities. Filtration of data should be based on employee ID. So this is the single property which is employee ID. This is the single property index, or single property on which we need to filter data and display those entities where employee ID is greater than 100 and less than 150. So this will be applying this kind of filter, single property index, because this is a single property on which you are querying the data. So this employee ID is the single property index, has to be created on employee ID, and this will give this kind of a result. So if you were to run this, further, so we are defining filter for an employee ID greater than or equal to 100. So we are defining over here employee ID is greater than or equal to 100. Then we are defining another filter, employee ID is less than 105. So these are two conditions, and then there is a composite filter operator, and where we are saying that this property filter as well as this filter both have to be applied as my filter. And then we set this filter to this query, and we sort this on employee ID and salary. And in this we are getting the result back, and in a for loop we are going to display the employees, their title and their salary being displayed in a for loop. This is what is being done in this example. So this is applying a composite filter. So now let's try to deploy this. Do you understand? This is the simple step of getting the project ID and pasting it over here. So this will create a single property index on employee ID, because we are creating a condition that the employee ID should be greater than 100 and less than 105. So this will create a single property index. So let's look at the steps which are given in the lab guide. Okay, so first of all what we do is we create a application single property index. Then we create all this, add the records. So we have said employee ID should be greater than or equal to 100, and question was what? Employee ID is greater than 100 and less than 105. So here, first of all, we are specifying greater than 100, then specifying less than 105, and then we'll make a composite index over here, composite filter, where two filter properties are going together in this filter object. Then we set the filter and all that, what we have already done and seen. So now let me just run this. So let me just run this. So I'm just closing the projects which are not required. So I've just pasted the code which is there for creating this single property index, and this will automatically create the index. We are not creating it. So let me run this. And check it over here. So this has done the filter and it has created the records. Now let me upload it onto the Google App Engine. So right now it is ancestor query. Now I am deploying single property index example. Let me wait for it to deploy. You can see over here total of 1 KB is being uploaded. So if 30 students type this command and try to upload, do you think they will be able to upload? if 30 people or whatever, 20 people in the lab, this is showing some values because I think so much data is already present. Let's look at the indexes. So this is 100, 101 and 102. So it has also got some built-in indexes. It has got entities, built-in indexes and composites. So you can see that this has already got built-in indexes which is around 35%. There are some 64% of entities. Just one second. So there are some built-in indexes using which this is getting created and getting deployed. And over here what we are doing is we are setting two filters. One is greater than, one is less than, and then we are setting the sort order on employee ID and salary, and then we are retrieving the values. So this was single property. Now let's look at the example of composite index which we will create. Currently it says composite index is 0. Let's see if we create a composite index or something. So let me run the second activity now. So in this, what we are doing is, again we are putting in the values of the records. 102 employee code, employee ID 99, 105, 100, 110. Now the difference over here is we are defining a new query and then we are querying on this filter where filter is great. This value of employee ID is greater than or equal to 100 and the title is equal to sales officer. So there are two fields. One is the employee ID and the title, and the sort order is also on the employee ID and the title, and there is also sort order on salary descending. So there are three sort orders and two filters being applied over here, and then once we get the results in pq.asIterable, we display the result. So let me just run this as per the instructions given. Along this, we will also be creating this file. This is how we define an index. Here we are defining that this is not automatically generated. We are defining a data store index of kind employee which doesn't have an ancestor, and this is manually done. And this will have in title, employee ID and salary. Title will be ascending, employee ID will be ascending, salary will be descending. So you can see over here the sort order of employee ID is ascending because we are not given anything. Sort order of title is also ascending and sort order of salary is descending. So salary is descending, rest two are ascending. And if we don't match this with what we want over there, then we will have errors. Because index will not be created, but we are trying to retrieve the data based on that particular criteria. So since this is matching, this should work. So now let's try to deploy this. File, new web application project. Form.example. Specify the composite composite index servlet tuple. Did I misspell it or something? Composite index servlet. Composite index servlet. Yeah, good example. Yeah, com.example. 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 Did I miss any step? I've been using a lot of shortcuts, but maybe did I miss anything? Let me create this again. Sorry. It's already existing. Now I've inputted it. Hopefully this should work. So now let me try to run this locally. Right now it's not giving the complete records. Firstly, the index, because of the property which is there, now it's got 2 records. But actually there will be more records. Yeah, there are so many records. Because of the property of eventual consistency, it's showing different records. Also, there will be a file which will be getting generated. All which we can create over here. In WebMIF, we are creating indexes manually this time. Right click, new file, so there will be a file called data store indexes, which open with text editor, and here we have to put in XML code if we want to create manually the indexes. So this is the syntax of that. Let me see if I have some files for that. So if this is how we have to create manual indexes, we can specify. This is XML format specifying the direction ascending, descending, descending for 3 properties. And let's run this, stop this and run this again. So it's coming as descending for employee ID, then sales officer same. Let me put it on the App Engine. Right click, deploy to App Engine. So the important thing to remember over here is the datastore.indexes.xml file, which has the XML format in which you can specify the indexes to be created, and this is using composite index, meaning it's going to be using composite indexes because the query which is running is complex. So as I told you in the morning also, some kind of error is coming, which is interesting. Let's look at the data store. Indexes status. So it's preparing one index which we have manually specified over here. You cannot see. So we have created an index which is title, employee ID ascending and salary descending. And right now the status is preparing. So that is why this error is coming. So once this preparing will become serving, then we will be able to see the records. If I continue running now, maybe it will take more time or it will add on more records. So I'm not running it again. I'm waiting for this to change. So let's wait how much time it takes from preparing to serving. Okay, we'll just get back to this. Let's continue with the slides and I'll come back to this when it changes from preparing to serving. So we were at this point and we are in also process of creating a composite index, meaning where two conditions are being given together, where last name is equal to this and first name is less than C. So this is the code, another example of how to use or create composite, or when you need to create a composite index. You have a book table. In this book table, we have a book ID, which is we are filtering on book ID is greater than or equal to 100 and author is equal to Peter. Two conditions are there. Author is Peter and this one book ID is greater than or equal to 100. So we define these two conditions as an and property filter 1 and property filter and property filter 1, and we apply it to this query Q. And we sort this now. We are again filtering as well as sorting. We're sorting it on book ID, author, price, and price is descending. So this is another example which would require a kind of a composite index. This is a problem which we have just now executed. It says you need to create an entities of employee kind which has got following tables, and web page should display data of employees whose employee ID is greater than or equal to 100, and web page should display data of those employees. The employee's title is equal to sales officer, and sorting out the data should be based on employee's salary. So three conditions are there. The web page should display the following entities as the output when running on the web page. So now I just got this as serving. So let me just come back to this window. So status has changed to serving. Now let's try to run this again. Right, now it's running. So it took around 2 minutes or so to create those indexes, and now it's coming. Employee ID is coming in the descending order, and it's filtered also on sales, and in the, what was the third condition? Sorting data should be based on employee salary. So salary is there. What was the condition we had given? Salary. Salary we have given descending, but I don't think it will work out because first it will sort on employee ID, and then title, and then sort direction salary. Descending. Okay, so we have the result over here. So you can experiment more with the queries and think of it how different it is from SQL. Here you have to create a class object and then create some more conditions and then set them as parameters, and then you can query or filter, which is very different than simply saying select star from table name, where some condition, order by this, group by this, having something, and compute and order by. So all that select statement has gone out. Now there are some functions and indexes, and so a lot of functions which require indexes to be there. So let me just look at the status of indexes. Probably we'll look at index status tomorrow if it is not updated very fast. So today we have created indexes. Tomorrow we will look at this getting updated. So the statistics over here is not showing much. Tomorrow when we look at it, hopefully there will be more values. So this is, statistics are updated at least once per day. So the statistics are not the latest one. Once a day they are updated, so we will look at it tomorrow when they get updated. So this shows also one more limitation of this thing, that you cannot have a count of records which are there or in the table instantly updated, because it uses the concept of eventual consistency. So one strategy is that we rely on this data store statistics for knowing how much of data we are using, how much of space we are using. But the problem is this is only updated once per day, and we'll have to wait for a day to be able to know how much of space we are occupying using for this query or for this particular database. So we'll have to wait. The other way is that you'll have to do some kind of another program you have to write to get it. So it's showing two indexes right now. So now coming to some more resources. Um, okay, I want to make you more uh, confused, let's say. So, okay, in YouTube there are Google I/O. Just type Google I/O. Um, this Google I/O is a event which Google does every year, in which it showcases its technology. Okay, so if you do a Google I/O and then App Engine, you will find a lot of videos which and it also Java, in which, yeah, here. So in 2012 I/O App Engine overview is being done. In 2009 Java persistent app engine, some discussion by Google is being done, and in 2009 they started serving Java. And what's hot in 2000 in Java for App Engine? So continuously they've been working on this over the years, and they have uploaded the events video for viewing, and you can also view them online at your time after this class. I mean, after your training is over. Not right now, there's no need to do it right now. I'm giving you additional sources of information for reading and understanding about App Engine. So there are this Google App Engine I/O videos on this site, plus this developers.google.com Java. Java App Engine Google. Okay. So there is this page. Link is this. This is a link. This is a link. This is the link. Cloud.google.com App Engine Docs Java Getting Started Introduction. These are additional links, additional reference reading links. Okay, so if you have to read everything about Java and App Engine, this is the link to go to, and this is the page which will open, and over here there is guides which are there on different topics. For example, testing and debugging, monitoring your application, uploading and managing your application, configuring App Engine, web.xml, storing data. Okay, this is data store. Storing data store, all about that. So this information, there's no, it's available from Google, which is very nicely documented. Storing documented over here. Cloud data store here, and data store indexes, queries, properties, keys and entities, data store transactions, authentication using OAuth. Memcache will come to tomorrow, day after we'll come to this. Um, Mobile backend. Sending and receiving mails. Probably tomorrow we will do this. How to send and receive mails from Google App Engine. Then also scheduling work outside user requests. This is also one more topic. Document and indexing. Reading and writing logs. So all this is information available on this page. And also there is I think we have some time. I will not start a very detailed topic, which is or the next activity, which will take time. But there is a small topic, for example, hello world in 5 minutes. Let me just do this, or try to do this in 5 minutes. It will not happen in 5 minutes. And also there is a creating a guestbook step-by-step tutorial online given. So you go to this introduction, then continue to set up, follow the steps which are given over here, try to understand them and try to execute after the course is over. Otherwise you may get lost right now. But I would also try to show you a small thing so that it helps you clarify certain concepts that are there. So first of all, okay. This I'm showing you right now is something which is kind of outside the, or it's not mentioned in the courseware, but still this is very interesting to do and for the understanding purposes. So over here I have Google Cloud Shell. I hope you are able to see it. So this is a new feature which has come in and I'm just using it, and I hope I am able to use it in the right manner. So additional learning material I have told you where to get. Forget this. I could have done it in Windows also, but I will have to install it. It will be more slower. So let me do it in over here. Let me just see if this gives me a connection now. So right now I have got a dollar prompt. Can you all see this dollar prompt? Say yes and clearly, because I will be using this to type something, and if this setting somebody's are not able to see. Let me ask this again. Can you see this dollar prompt now? It's a small one, but it is there. Okay, in this you can just do a small command, copy paste from here, git clone. Where did it go? So when I say git clone some path there given on the site, hello world site, So a sample application has got downloaded onto my Cloud Shell, and after that, what I have to do? So I have to go to cd java docs samples app engine. I have to go to hello world. I am into hello world, and so there will be a file called there's a file which is there in this structure. When I say ls, there is a pom.xml, there is src, there is main. So complete folder structure has come in actually. Here is Java, com, example, app engine, hello world. So this is hello world servlet. This over here, I can open it VI over here and change this hello world to my message so that I know I have changed it. I have to go back. There is no other way. Connection is lost. So somehow connection got lost. So I have to be in this folder where pom.xml is there. Okay, in this folder, I can open this pom.xml and give no, I don't need to change this. I don't need to change this. What I do need to change is app engine web.xml. This is going to be present under some folder. I hope in 5 minutes I can do this. Whatever we have been doing through Eclipse, I'm just trying to do it using command line. So app engine web.xml is file is there. Here it says your project ID. So your project ID is what? What is your project ID? and version, let's say 1. This I have specified. Okay, now what I need to do. Web.xml. I'm not changing this. Okay. Okay. Now I can do the testing of the application locally or I can upload it. I'll directly upload it. All I have to do is say Maven App Engine update. So paste it, and this will take 5 minutes to download some files, APIs. Hopefully it should work. It will read the POM files, start compiling just like it does in Eclipse. However, since we are doing this first time on this server, it will take some time to download all the files, and then it will deploy it. So the download has started, and download will be pretty fast because this is happening on Google server, and their speed will be pretty good. But I'm sure we'll be able to see the answer also, the output also, very soon. So till that time, let me just see what is next. I'll get back to this as soon as the download is over. So next is we'll also update tomorrow morning, first thing, the application which we had created in the today morning. Insert, update, delete. We'll add more features over here: view, search, filter, sort to it, and so that's about what we'll be doing tomorrow morning. Indexes is what we had covered today, and also filtering and sorting. So indexes in Google Data Store required to perform queries, and they are must. Indexes is defined on list of properties of a given entity kind. Index can be also optionally included in entities and sisters. Google Data Store uses single property index for queries that contain simple filters and sort operations. Composite indexes are used with more complex queries that use inequality filter on one property and combining with equality filter on the other property. If two entities contain properties with the same name but different value types, the first index of the property sorts the entities by value type and then sets the order that is suitable to each type. Property defined as unindexed ensure that sorting and filtering operations cannot be performed using that property. So there is an unindexed keyword. If you give that, then we cannot index that particular field or property. And we also see transactions tomorrow. So your work for today is to get your data, at least the delete data part done. Just if you're not able to download, assemble the thing together, use the solution which is provided to upload and see the working of the delete data. Probably should be having the working for other parts also. That is insert, update, retrieve and delete. So try to do the upload of solution of delete 7.4 exercise number, and then also try to figure out if you can try out the indexing part. filtering and indexing, how it is working, and can you see that part where it is preparing for index? Are you on your screen able to see where it is preparing for index when you are filtering or when you are querying for a particular value? So these are the two things. Anything else you would want to talk about? So okay, so how? Hopefully for attendance you had sent me a mail by today. You have sent it hopefully, and I've given you additional information to read on or view videos to watch also, which you can do later on when you're more comfortable with Google App Engine. And as I was showing you the home page of Google also, there is a video. Here, for example, this is what is there are videos like over here. Links are given on the home page, which I was mentioning, or maybe this is a different page. Link, additional reading, video watching, cloud, google.com, app engine, docs, Java, getting started, introduction, right? Same link. Over here you can see auto scaling Java, introduction to data stores, data store queries and indexes, transactions. This is the video which we saw today. Memcache, basic, task queue are some more things which we will study. So this is on YouTube.
We'll now discuss more advanced data store topics on query, index, and transactions. These are 3 topics on.
So the video which I showed you is there on YouTube. Okay. Now what has happened is it's come to a point where okay. So you can see over here it's asking for code. So to get the code I need to copy this URL and paste it in my browser. I will give the permission for this to use it. I get this code and I paste this code back into this place. This is like giving the permission to deploy. So just like in Eclipse, there is sometimes it was asking for code. It has given a URL. I took that URL and pasted it in my this thing, and when I have added this thing, I've added a code now. Now it's continuing. Probably some more. Now it's done. I think it's done. Let me just run this. Let me run this. Run. Oh, some problem. It's not updated. Access code is invalid. Okay, so maybe I made some mistake. Enter some code. Take this code. enter. Yeah, now it's uploading, deploying. And it is done. So now let's see. So you can see the output come now as. So right now what I just showed you was how you alternatively people can also use command line Maven to do this compilation, but don't have to worry about this. This is beyond the course, and I was just showing off. This is not to be used right now because we are using Eclipse, and we are okay, comfortable. Just get comfortable with Eclipse. Forget that we saw this. So this is just additional information which I gave you. So this is also possible. Through Linux also you can upload, and through command line also the files can be made. So any more questions for today? So how was your session today, or how is your experience with Google App Engine? You're finding it okay to study this concepts now that the initial part is over, where we were not able to connect to Google App Engine? So only very few people have said plus. Can you say plus more? So good. I can see 30% have said yes, they are okay. Please let me know how you're finding this. Yeah, okay. Yeah, so now you have, when I say get your hands dirty, spend the night to practice. Keep on uploading, deploying, uploading, deploying. And right now, don't worry about the syntaxes too much. Take in the steps of how to deploy, how to configure, how to build it together, what is the output coming from the app engine. You will get used to the syntaxes and the commands shortly, and right. So I'm getting a signal to wind up now. So tomorrow again we'll have only tomorrow till 3:30, but please be here by 8:30 or quarter to 9 at least, so that we can all start, and so we can end the session for today and see you tomorrow. Thank you.